Hello students, welcome back. Our game is coming along exceptionally well. In fact, I'd say that it's completely playable. We're pretty much done. In this video, we're just going to add some game polish, make it look better, make it play just slightly better. And we're going to focus on three systems here in this game polish lesson. The first system, we're going to add a pulsing effect to our residues, so they'll sort of grow and shrink. And this will make it look like they're truly radioactive. We'll also add a brand new overlay, a window that sits on top of our game window, for when we're about to die. If our containment gets too low, we'll have a flashing effect that warns the player that, hey, you better do something, or it is going to be game over. And finally, we'll add an effect that every time we score a goal, whatever goal we score or can put our radioactive cells into, that goal will light up. It'll flash to give a bit of visual feedback. So why don't we head to the computer screen and we'll dive right in. All right, so I have lesson 8 open here in vscode.dev, our game polish lesson. And let's minimize this window and let's open up that file directly. So I'll open up lesson number 8, our starter file, and let's see what we got. All right, so do we got any of this polish in? So I'll score a goal, nothing lights up. Let's see if our residue system is going to be animated. Anything? Let's see. So we got our color lerp, which looks cool. Nothing. Our residue is completely static. And let's just check. If I'm about to die, am I going to get a warning overlay? No warning at all. So none, zero, zilch of these systems are in place. So that means we just got to do a bit of work here. So the first thing we're going to do, mission number 1, we are going to adjust the polish constants. So let's search for the mission 1 tag. And hopefully it's no surprise. These polish constants, these variables that we can tweak to change the feeling of our game are right here in our student edit zone, right? So we're going to define some data. So if I scroll down, we've got, what do we got to work with? We got 2 variables that we can work with. A low containment threshold and then a goal flash duration. All right, so our low containment threshold is currently set to 75. That seems super high because what's our max containment? Isn't our max containment 100? Yeah, our max containment was 100. We don't want to start warning the player that they have low containment when it's at 75 because that's pretty good. We want to warn them when it's like, I don't know, super low, like 10 or 20 or 30. I'm going to keep it at 30. So when it's at 30, 30%, when it's at 30, we'll start warning the player that, hey, you got to do something. And then we've got this goal flash duration. Anytime we score a goal, we want to make the goal light up. So if I have a cell that's right here, zoop, 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 all right, and I score it in this particular goal, this goal should light up. But 2.5 seconds is a very long time. That goal would light up for 2.5 seconds. I think that's like ridiculously long. So why don't we change that? Let's adjust it. I'm going to put it at 0.60 seconds. And then you can tweak these and see what you like. How does it feel for you? And then change them accordingly. So mission number 1 is done. Mission number 2, we are going to look in our draw residue function. We got to set up this pulsing. And so right now we've got this variable called pulse and it's set equal to 1. It says add pulse behavior to the radioactive residue. Use a sign-based value to drive our visual changes. All right, so we should probably talk a little bit about what a sine wave is. And in order to help us, I'm going to go to our whiteboard. Ooh, lovely. A little math lesson or a little physics lesson. So a sine wave is just something that repeats itself over and over and over again. So ready? Watch this. Here's a sine wave. It goes up. Oh, that's my eraser. Let's try that again. It goes up, goes down. It goes up, it goes down. It goes up, it goes down. And it just keeps doing that, up and down. All right. Now, this is really great because if we think about this, this value right here is 0. And then let's just assume that this is going up to be like, I don't know, 1 in the positive direction. And then this right here is all the way down at 1 in the negative direction. So we're 1 unit away up and 1 unit away down. A sine wave is something that is called cyclic. So it increases in size, and then it decreases in size back to 0. Then it increases size in the opposite direction, and it decreases size back to 0. And it just cycles this over and over and over again. But we can have different types of sine waves. So for example, I could have a sine wave that is taller or bigger. Instead of going to 1 in both directions, it could go, I don't know, maybe up to like 2 in both directions. All right. It can grow larger. And so maybe now this is 2. So 2 units up from 0, 2 units down from 0. We call that measurement right here of how big it's getting, we call that amplitude. The amplitude. All right. So that's going to be important for us. How much do we want our pulse to grow outwards and inwards? We're going to trigger that via the amplitude. And then there's also another important property. So I'm going to just draw another sine wave here. So here's a sine wave. Zoop. And let's just say in one, I don't know, arbitrary measurement, so like all the way right out here, right? Imagine I could have the sine wave go up and down and up and down and back. So if we look here, I actually have one waveform, one sine wave right there in yellow. And then here is another sine wave in green. I fit 2 sine waves in that space. But I could have a different sine wave that maybe is going up and down at a faster rate. And if I do that, right, so maybe I go up and down and up and down and up and down and up and down. Instead of fitting 2 sine waves, I've actually fit 4 sine waves. And the cramming of waveforms in some given region has a special name. It's called frequency. All right? If the frequency is higher, it means it's going to go from its highest point to 0 and its lowest point to 0 faster and faster and faster. All right? You can think of this as like the rate at which it is moving from 1 to 0. So think of amplitude as how big it's going to be, and frequency as the rate at which it's going from its highest value to its lowest value. And we're going to use amplitude and frequency and a sine wave here to define our pulse, because we want our residues to grow and shrink and grow and shrink. They're going to pulse in and out to give that effect. So let's change this from 1, and let's call the sine function to generate a sine wave. Now, inside of here, we're going to put our frequency. All right. And then we're going to multiply by our amplitude, how big we want it to be. So let's do our amplitude first. I'm going to make my amplitude 4. Okay. So that's just a measure of how big I want this pulse to be. And then my frequency, what I'm going to do is I'm going to take my run time seconds variable, which is going to keep track of how long the game has gone on. And so this is a value that will vary. It will change because it gets bigger and bigger and bigger and bigger. And I'm going to multiply it by... I'm going to multiply that by, let's multiply it by 4. All right, so this is going to represent our frequency. Now, runtime seconds gets bigger and bigger and bigger and bigger and bigger. Runtime seconds gets bigger and bigger and bigger and bigger. And what you can see is our wave just keeps repeating over and over and over again. So now we have our pulse set. So what we have to do is, I think mission 3 is right below us. It says draw and animate the residue pulse effects. Because right now, even with that pulse defined, I don't think we're drawing it at all, which is kind of a bummer. I really want to see this in action. Let's take a look. So is it going to animate? Is it going to pulse in and out based on a sine wave using frequency and amplitude? No, it's pretty static, right? So what we have to do is when we draw our residues, we somehow have to use that pulse. So let's think for a second here. I've got my residue radius, all right? So this is the center point of the circle, and then this is the size of the circle. So the size of our circle is never changing. So what I'm going to do is I'm going to do plus, let's just do pulse. And let's see if that fixes it, because this value will change. The sine wave is going to go up and down and up and down. And let's take a look. Refreshing the page. All right, there's my first cell. Let's get a residue, let it explode, and let's see if the part of it's going to start animating. Oh, look at that. That looks kind of cool. It is starting to animate, but it's just the outer part. I kind of want everything to animate. So I'm going to do something similar to the rest of them. I'm going to add pulse, and I'm going to add pulse. And let's see how this looks. Let me click off of that. All right, so now let's take a look, and let's see if all three parts of the residue begin pulsing in and out. So I'll move that right dead, center so we can see it nicely. All right, let's take a look. Ooh, that looks pretty good. We could probably like fine tweak that effect too. Let's do that. So for our outermost, we'll multiply by the entirety of the pulse, and then for the next one, let's multiply by a smaller bit, so it's not as powerful, 0.7. And then for the innermost part, let's multiply by an even smaller number, 0.3, so it's even less powerful. So the most radioactive part is going to be on the outside, and the least radioactive part, the most maybe stable part, will be in the center. Let's see if we can, if we like that pulse effect a little bit better. Ooh, yeah, I like that. It almost looks like it's sort of like breathing. Now let's go and let's just mess with these parameters here. We said this is going to be our frequency, so let's up this from like, I don't know, 4 to, let's set it to 10. So if I do that, the frequency, or how fast we should go from our highest to lowest values, is going to increase. So let's see. Hopefully now that pulse is going to be a lot faster. Let's just see. Let's see if we see it. Yeah, there it is. Okay. And I don't think I like it, but it's there. It's good to see it. And let's change the amplitude. Let's make the amplitude, instead of 4, let's set the amplitude to like 20. That means we should be growing much larger in our pulse. Let's see if this is making sense. If our math explanation is correct, because it's important to kind of sort of understand the math. I know that's maybe not what people want. Whoa, look at that. All right, so now it's just gotten bigger. And let's change this to like 100. Let's just be funny with it. Let's change it to 100 and let's see what happens. We're going to get a super fast pulse. All right, let's see. Oh my goodness, that hurts my eyes looking at that. I don't like that. But I want to be super funny. I want to be super funny. Let's just change this to like, I don't know, 250. Whoa, not 2,250. 250. Let's just get crazy with it. And then I will get back on track. I'm just having too much fun right now, just messing around with these things. So let's put that here, and we're gonna have a super fast pulse that is super, super large. What? Oh my goodness gracious. That is, I don't know about you guys, that's hurting my eyes. I have to stop. Let's set it back to an amplitude of 4 and the frequency of runtime seconds times 4. But with that, our pulse animation is set. That polish is done. We did mission 2 and mission 3 all at the same time, which is great. We're now on to our next game polish system, which is detecting low containment conditions. So mission number 4, if we are at a low enough containment, we want to begin to flash an overlay on the screen. So if you look here, we're inside draw scene, and it's going to be with overlays. We don't always want to draw our overlay. We only want to draw an overlay if a certain condition is true. So we're going to ask a question, and that question, if the answer is correct, then we need to, I'll just tab it over here, we got to draw the overlay. Well, let's go see if we have the overlay. So if I scroll down, we've got draw containment bar, draw ramp readout, draw low containment warning. I feel like that's going to be our overlay. Look, it's right next to draw start overlay and draw lose overlay. So here is our overlay. It's called draw low containment warning. We don't want to always draw the low containment warning. We only want to draw it if a certain condition is true. So what is that question going to be? It's going to be, is our containment variable, so containment, if that is less than or equal to, if you remember, we defined a constant, the low containment threshold. I think I set it to 30. So if it's less than or equal to 30, I am going to call the correct function draw low containment warning. All right. So I think mission 4 is now done. Let's see what happens if I get to a low containment warning. Get out of here with those crazy cells. That was nuts. That was too much. All right, so let's take some damage here. All right, I'm going to push all the cells right to the middle. Zoop, zoop. All right, taking damage. Pretty soon, we should be... All right, so I should have triggered that. That should have triggered. So this definitely triggered because our containment was less than the low containment threshold. So this function should have been getting called. This question evaluated to yes. Well, let's go see what mission 5 has us doing. Mission 5 puts us right into the draw low containment warning. And so here it says display and animate the warning overlay. Flash a border when containment is critically low. So it looks like what we're doing here is I ask a question, I have an if question, and this basically just says that like, hey, every now and then, okay, when this function's running, just get out of the function. Don't do this. So maybe the first time it runs, do it. The next time it runs, just skip it. Then the third time it runs, do this. The fourth time it runs, skip it. The fifth time it runs, do it. The sixth time it runs, skip it. All right, that's all we're doing right here. So let's look at what we have to do when this function actually runs. We're saying no fill. Put no paint in my paint bucket, but give me a marker of a specific color, my low containment warning. And let's make it a very thick marker, a marker whose weight is 12. Our low containment warning, if you look at it, it's got an RGB alpha string. It's got all of the green, a decent red, and just a little blue. So it's going to be like a greenish, maybe yellow color. And it's got a transparency of 0.5. So we're going to use that to flash a border. So I'm going to make a rect. A rectangle is going to be my border. It's going to start at x coordinate 0. And its y coordinate, well, let's see. I don't know if I want to be the full window or just the gameplay window. I think I want it to just be the gameplay window. So it's going to start at x coordinate 0. The y coordinate is going to be right down here. It's going to be where the HUD height starts. So I'll do HUD height. And then I need the width. The width of the rectangle is going to be width. And the height is going to be my height variable minus the HUD height. So I got to subtract that HUD height off here. All right, and so now let's see if that rectangle gets drawn. We're not filling the rectangle in because I got no paint in my paint bucket. So it's just going to be the outline of that rectangle. Let's take a look. I think this system is going to work pretty nicely. Let's just see. We just got to let it get down low. We got to let it get down our containment to under 30. All right. So, I'm so slow moving through those. I got to say, this game looks pretty cool now with these and look at that. There is our bordered animation, our warning to let us know that bad things are going to happen if we don't do something. So I'm pretty happy with that overlay system. Let's see what mission 6 has us do. We need to prepare the goal flash system. All right. So mission 6 takes me into reset game to defaults, which is where we define our goals array. So we define it here because once we define this, we're never changing the goals. They just always stay the same. The goals have an X position or an X property, a Y property, a width, and a height. But we need to add one more property because when I score a goal, all right, so like on this goal right here, I'm going to score a goal. Let's just say zoop. Okay. I need to flash the goal and then keep track of how long that flash has occurred. And then when it hits 0, put it back to its normal drawing. So what we need to add is essentially a timer to each of these objects. And so we're just going to come over here all the way to the end and we're going to add a new property called flash timer. So I'm going to hit comma after goal depth and I'll do flash timer and I'm going to give it a value of 0. Because if we made this non-zero, right, if I had it like 10, it would indicate that we want this goal to be lit up for like 10 seconds. And I don't want that. I want it to be set to 0, not lit up at all. Now, I'm going to show you a neat little thing. If you hit Alt on your keyboard and you click right there after goal depth, hold Alt, keep it down and press with your mouse right here, and then hold it down still and press with your mouse here, you get multiple cursors. And so now I can just fill the rest of those in, comma, flash timer, 0. Multi-cursor is awesome, but be careful. If you have multi-cursors and you make a mistake, you just made multiple mistakes. I think Spider-Man said it best, with great power comes great responsibility. Although that wasn't Spider-Man, that was Uncle Ben that said that. But it happened in Spider-Man, I think. All right, so now our goals are set to have a timer that will keep track of how long they should be flashed for. And right now when we start them, it is all set to 0. So let's see what mission number 7 has us do. Mission number 7, we got to trigger a goal flash feedback on a successful save. So when we save a cell, right, when we contain a cell, we want to take that flash timer and do something with it. What are we doing right now? Well, for the particular goal that just got scored on, because this is in the function check goal cell or cell goal collisions. So a cell just collided with a particular goal. So we know what goal we collided with. We're taking that goal's flash timer and we're setting it equal to 0. Well, that's not right. That would mean that we want to not light the goal up at all. So I got to set it to some duration. I can set it to like, I don't know, 1 second or 2 seconds or 3 seconds. But if you remember, we had a constant variable that we set for this system way back at the beginning of this video. It was called goal flash duration right here. What did we set it to? 0.6 seconds. So we're setting the timer. All right. So now our timer is set. Let's see if I score a goal, is this going to light up? Let's just take a look. Nothing. I wonder why. Well, we defined data. We updated the data right here. What is the last step of this process? Mission number 8. It puts us in our draw goals function. Of course it does. We defined the data. We updated the data. And now the last and final step of our game, Corefall. We got to draw that data. So if you look right here, it says animate and render the goal flash effect. Use the timer, which we just set, to control visual feedback of the goals. So right now, our paint bucket is got the goal fill color. All right. Well, let's just see what other colors we have. If I do goal, I also have a goal flash color. See, I have goal fill color and goal flash color. Let's just see, what if I make it goal flash color? So there's our regular goals. And there's our flashing goals. That's what it's going to look like when we score a goal. But we don't want to just keep that there all the time. We only want to put this paint in our paint bucket if the goal, the specific goal that we're on right here in our for loop, if its flash timer is greater than 0. And so what we're going to do is we are going to ask a question. And we saw a nice way that we could ask a question using something known as a ternary operator. So here's our question. Goal, the goal that we're on, we're going to target its flash timer property, flash timer, if that is greater than 0. Okay, so that is our question. Is the goal's flash timer greater than 0? If it is, what will I use for the fill function? I'm going to use the color goal flash color, colon, and the colon is now going to give us what we use if the answer is not yes. If the goal flash timer is not greater than 0, then we're going to use this value, goal fill color. So now we have a way to dynamically put paint in our paint bucket and change the color that we use to draw our rectangles. I think our goal flash system is all set and it is in place. And with that, I think Corefall is complete. Let's take a look. Let's play it out. So I got this nice movement going on. All right, let's score a goal. Hey, it lit up nice. Got some nice visual feedback. Oh my goodness, I missed it. All right. That's kind of cool. I like that a lot. Let's get some cells blowing up here. Let's get some cells blowing up. All right, our cells are blowing up. I try to move. It slows me down. All right. Oh, my goodness. I don't know if I can keep up. I got 2. Oh, no. All right. Oh, no, there's our warning. All right. Oh, when we go back above 30, it stops, so that's good. All right, can I get back? Can I get it back? Can I get it back? Can I get it back? No. Guys, it's not good. It's not good. We're going to have nuclear meltdown here. Oh, look, we got back over 30. But this definitely gets hard with the slowdown in place. Oh, no. Oh, no. Oh, no. Oh, no. Oh, no. Oh, no. I'm thinking I'm done. And there we have it. Reactor failure. I scored 14. I saved 14 cells. I'm pretty happy with that. I think it's pretty good. Of course, you guys are probably playing it going, I saved 300 cells, 500 cells. But the point, it doesn't matter how many cells we saved. The cool thing is that we actually took a broken, unplayable game in that first lesson. And in 8 lessons, we made it into something playable, fun, and impressive. I think this is a great place to stop, and I'll see you in the next video.